Section 7.4 is about the remainder and the factor theorems. Let's look at a polynomial and divide it by a binomial, in this case an a minus 2. If I divide my polynomial by this binomial, I get a remainder of 16. Whether I do long division or synthetic division, I still get a remainder of 16. And I want you to compare that to what happens if I take the number 2 and I plug it into the function. I get a solution of 16 if I plug a 2 in, which leads to an interesting observation, that when I take the number on the end of my binomial and plug it into my function, I get the same thing as if I divide the function by my a minus 2, my entire binomial. And that leads us to what the remainder theorem is all about. Now, I'm not going to try to explain this in the theorem form. I think it's easier if we look at examples. So on the next slide, I'm going to give you a definition of something called synthetic substitution and tell you that that's another way of evaluating a function, especially when the degree is bigger than 2. Look at this function. This has a degree of 4. And we certainly could plug f of 6 into this function. In fact, we're going to do that to just show you what we get if we plug a 6 in. So this is certainly a calculator problem. In fact, I'd like you to pause the video and plug all this in and see if you can find out what the value of f of 6 is in this polynomial. So here we got 2,453. Now we're going to compare that value with the new substitution that I'm about to show you, which is called synthetic substitution. So if we want to find f of 6, we basically want to pretend as if we're going to divide my polynomial by x minus 6. Because remember back here when we looked at this case, dividing by a minus 2 was the same as plugging a 2 into the function. So plugging a 6 into the function is the same as dividing this by x minus 6. So I'm going to use synthetic substitution. The number that comes after the subtraction sign goes in this little box. And then we use the coefficients of the polynomial. So 2, 0, I need to use a 0 because there is no x cubed, and I have to have a placeholder, -5, 8, and -7. So now we use synthetic division or synthetic substitution to solve this. Bring the 2 down. 6 times 2 is 12. Add, you get a 12. 6 times 12 is 72. Add, we'll get a 67. 6 times 67 is 402. Add those together, we get 410. And then 6 times 410 is 2,460, which when we add to -7 is 2,453, which is my remainder when I use synthetic division, but that's also the value when I plug f of 6 in. So you see that we can plug values in using the function, but we can also use synthetic substitution to find what a function evaluated is at that number. Here you see the definition of a depressed polynomial, and know that it's not a polynomial that's sad. It's a polynomial that has 1 degree less than the original polynomial. And that leads us to a factor theorem, which says that if we're going to say that this binomial is a factor of some bigger polynomial, we can only say that if it goes in evenly, if the remainder when you plug or do synthetic division of the a is a 0. Now what does that mean? Let's look at this next example to see that. We want to show that x plus 3 is a factor of this polynomial. We want to prove that it's a factor of that. And here's how we do it. X plus 3 is really x minus -3. So I'm going to use synthetic division and see if -3 goes into this polynomial. So I use the coefficients 1, 6, -1, and -30. And so we'll use synthetic division to see if this works. So 1 plus nothing is 1. -3 times 1 is -3. Add them together, get a 3. -3 and 3 is -9. Add together, get -10. -3 and -10 is 30. Add them together, you get a remainder of 0. So because of the factor theorem that we just looked at, the factor theorem, we found the remainder was 0. And if we find the remainder is 0, we've just proven that x plus 3 is a factor of this polynomial. Furthermore, we've also shown that if you take the x plus 3 out, you're left with a new polynomial of 1x squared plus 3x minus 10. And where did I get those? I got those from the coefficients of the synthetic division. And remember, when we do synthetic division, we always do 1 degree less than the one we started with. So that's why I started with an x squared. This is called the depressed polynomial. It's a new polynomial that's created when I pull out the factor of x plus 3. Now we can continue, because if you look at this trinomial, we can factor that. We know two factors of negative 10 that add to be 3, positive 5 and negative 2. So we're going to continue to factor that. And we find out that there are 3 factors to this polynomial: x plus 3, x plus 5, and x minus 2. In this example, we're given the volume of a rectangular prism, and we want to find all the missing measurements. We do know one of the measurements is a binomial, x minus 4, so that leads to synthetic division for me to help find the other ones. I'm going to take the 4, because remember that's what comes after the minus sign, and I'm going to list the coefficients of my polynomial: 1, 3, negative 36, and 32. And I'm going to see if I get a remainder of 0 or not. So bring down the 1. 4 times 1 is 4. Remainder of 7. 7 and 4, 28. Remainder negative 8. And negative 32 with a remainder of 0. So we've just proven that x minus 4 is one of my factors, and even better, we've shown that what's left over is a 1x squared plus 7x minus 8. Now we hope that this trinomial can be factored. Are there two factors of negative 8 that can add to be 7? Positive 8 and negative 1 looks good. So the missing measurements of my rectangular prism: x minus 4, x plus 8, and x minus 1.